Polaris Dawn mission is finally ready for launch. NASA decided to bring Starliner back home without crew, and RFA experienced an anomaly during engines testing, and there is much more coming up in this week's Space Updates.
NASA has decided that Butch and Sonny will return with Crew 9 next February.
NASA will return Boeing's Starliner to Earth without astronauts Butch Wilmore and Suni Williams aboard the spacecraft. The agency announced Saturday the uncrewed return allows NASA and Boeing to continue gathering testing data on Starliner during its upcoming flight home, while also not accepting more risk than necessary for its crew. Wilmore and Williams, who flew to the International Space Station in June aboard NASA's Boeing crew flight test, have been busy supporting station research, maintenance, and Starliner system testing and data analysis, among other activities. Wilmore and Williams will continue their work formally as part of the Expedition 71-72 crew through February 2025. They will fly home aboard a SpaceX Dragon spacecraft with 2 other crew members assigned to the agency's SpaceX Crew 9 mission. NASA's commercial crew program requires spacecraft fly a crewed test flight to prove the system is ready for regular flights to and from the space station. Starliner is designed to operate autonomously and previously completed 2 uncrewed flights. Back to June, NASA and Boeing identified helium leaks and experienced issues with the spacecraft reaction control thrusters on June 6 as Starliner approached the space station. Since then, engineering teams have completed a significant amount of work, including reviewing a collection of data, conducting flight and ground testing, hosting independent reviews with agency propulsion experts, and developing various return contingency plans. The uncertainty and lack of expert concurrence does not meet the NASA's safety and performance requirements for human spaceflight, thus prompting NASA leadership to move the astronauts to the SpaceX's Crew 9 mission. Starliner is expected to depart from the space station and make a safe, controlled, autonomous reentry and landing in early September. Starliner must return to Earth before the Crew 9 mission launches to ensure a docking port is available on the station. Following Starliner's return, the agency will review all mission-related data to inform what additional actions are required to meet NASA's certification requirements. The NASA SpaceX Crew 9 mission, originally slated with 4 crew members, will launch no earlier than Tuesday, September 24th. The agency will share more information about the Crew 9 complement when details are finalized. NASA and SpaceX currently are working several items before launch, including reconfiguring seats on the Crew 9 Dragon and adjusting the manifest to carry additional cargo, personal effects, and Dragon-specific spacesuits for Wilmore and Williams. In addition, NASA and SpaceX now will use new facilities at Space Launch Complex 40 at Cape Canaveral Space Force Station to launch Crew 9, which provides increased operational flexibility around NASA's planned Europa Clipper launch. The much-anticipated Polaris Dawn mission is scheduled to launch on Tuesday, August 27th. Falcon 9 will lift it off from the historic Launch Complex 39A at the Kennedy Space Center in Florida. Last week, the Polaris Dawn's crew arrived at NASA's Kennedy Space Center and completed a full rehearsal of launch day activities ahead of liftoff. Falcon 9 booster B-1083 will launch Crew Dragon C-207 Resilience on its 3rd flight, with Resilience having previously flown the NASA Crew 1 and Inspiration 4 missions. Polaris Dawn's commander is Jared Isaacman, who previously commanded the Inspiration 4 mission in 2021. Scott Poteet, a longtime friend and business partner of Isaacman, will be the mission pilot. Poteet served as the mission director for Inspiration 4. Sarah Gillis and Anna Menon will serve as Polaris Dawn's mission specialists, with Menon also serving as the medical officer. Both Gillis and Menon are SpaceX engineers who have played key roles in astronaut training and mission control operations. Resilience has been modified for one of the mission's primary goals, to complete the first extravehicular activity, EVA, by commercial astronauts at an orbital altitude of 700 kilometers. The crew will don newly designed EVA spacesuits, and Resilience will be depressurized. Isaacman and Gillis will then exit the vehicle through the modified top hatch and perform a tethered spacewalk, while Poteet and Menon stay inside Resilience. Building a base on the Moon and a city on Mars will require thousands of spacesuits. The development of this suit and the execution of the EVA will be important steps toward a scalable design for spacesuits on future long-duration missions. Another mission goal is to be the first to test the Starlink constellation's laser communication systems in space, providing valuable data for future space communication systems necessary for missions to the Moon, Mars, and beyond. While in orbit, the crew will conduct scientific research designed to advance both human health on Earth and our understanding of human health during future long-duration space flights. 36 experiments from 31 partner institutions from across the world have come together to produce one of the most robust and diverse science and research portfolios ever slated for a spaceflight mission. They're using ultrasound to monitor, detect, and quantify venous gas emboli, VG, contributing to studies on human prevalence to decompression sickness, and gathering data on the radiation environment to better understand how space radiation affects human biological systems. By providing biological samples towards multi-omics analyses for a long-term biobank, and research related to spaceflight-associated neuroocular syndrome, SANS, which is a key risk to human health in long-duration spaceflight. The mission is expected to last up to 5 days, after which Resilience will deorbit and perform a controlled splashdown. SpaceX recently shared that Flight 5 vehicles, Ship 30 and Booster 12, are ready for flight. Teams have been adding decals to Ship 30, including a small Mechazilla decal, to represent the goal of this mission, which is catching the booster. New ship methane header tank design was spotted next to Star Factory. The header tank storage the fuel and oxidizer for Starship landing burn. This one slated for Ship 34. The first Block II generation ship continues stacking. The remaining oxygen tank sections rolled out for stacking. The final Ship 33 section, the aft section, moved from Star Factory for stacking with the ship. The teams began working on the thermal heat shield tiles, as many of them installed on the welding places. This week, SpaceX transported Test Tank 16 to Massey's test site. This test article related to Block II ship's hardware testing, and later it was lifted into the new test stand and the structure cap placed on place, getting ready for some structure testing. On Sunday, 3 new tanks spotted heading towards Brownsville Port have arriving at the Massey outpost. Moving to the launch sites, Pad B Tower Final Module, Module 9 moved this week from the Sanchez to the launch site. Starship's second integration tower at Starbase is now fully stacked. SpaceX completed this in just 41 days, which is faster than the other 2 towers that were built. Also, this tower is already far more complete, with all of the commodities lines installed beforehand. With the tower fully stacked, teams have to finish welding all the modules together and fill the columns with concrete. Once this is complete, teams can finish the chopstick carriage tracks, which are needed before the carriage can be installed on the tower. Along with the installation of the chopsticks, a full ship quick disconnect arm is also needed. So far, there has been no sign of this being built, and SpaceX is unlikely to use the one built at Roberts Road, as that one is far outdated at this point. The drawworks must also be installed and reeved through the tower once the chopstick carriage is installed. An entire Trench Plus pad needs to be built and installed. All commodities lines, pumps, and subcoolers need to be installed and hooked up to the current tank farm. Work continues on the orbital launch mount. After B14.1 was removed from the OLM, teams began to expose all of the significant weld lines on the chopstick arms. Once exposed, doubler plates were welded onto the weld to strengthen them. Teams have also installed a new set of bumpers made of a compressive metal structure rather than foam or rubber. SpaceX is also removing some of the landing rail dampers recently installed on the chopsticks and changing out even more hardware. As the booster comes in, both arms close quickly and possibly hit the booster right on the methane tank. The booster then slides down the sticks until the lift pins contact the landing rails, helping slow the booster down and acting as a shock absorber. Then the pins rest in the inserts and the engine shut down. Overall, with all of the work going on around the pad, it is kind of impossible to tell when SpaceX will be ready to fly Flight 5 from this pad. It's going to be a game of waiting to see all of the equipment being cleaned up around the launch site, to see when crews might be finished. Flight 5 is likely several weeks away, even based on perceived vehicle readiness. SpaceX also requires regulatory approval for this mission, including the booster's return to launch site. On Monday evening, rocket Factory Augsburg conducted a hot fire of its first stage at their launch site at Saxavord Spaceport. RFA plane was to conduct a static fire with all 9 engines for the first time, start with the center engine, and then pairs of 2 engines with a small delay, and the test aims for a total duration of 35 seconds. 8 of the engines were ignited successfully, but unfortunately one of the engines had an anomaly. According to the company's statement, the anomaly was very unusual and was most likely a fire in the oxygen pump, and the damage has spread on to neighboring engines. The engine's propellant manifold was damaged to an extent that led kerosene to kept fueling the fire, and the fire turned into an oxygen fire at later and compromised the entire thrust frame structure of the stage, and the entire stage collapsed. This first stage booster was made for the rocket first launch. The future first stages will have many improvements. Mostly are related to propellant manifolding to pressurization system manifolding, and those improvements will help the company to sustain the engine's damage in flight and on the pad without losing the booster stage. No one was injured in the process. The launch pad has been saved and is secured. The situation is under control, and any immediate danger has been mitigated. RFA now working closely with Saxavord Spaceport and the authorities to gather data and info to eventually resolve what happened. This week, the European Space Agency's Jupiter Icy Moons Explorer JUICE has successfully completed a world-first lunar Earth flyby, using the gravity of Earth to send it Venus-bound, on a shortcut to Jupiter through the inner solar system. The closest approach to the Moon was at 21:15 Universal Time on August 19th, guiding JUICE towards a closest approach to Earth just over 24 hours later at 21:56 Universal Time on August 20th. The purpose of the flyby was to reroute JUICE's path through space, using the gravity of first the Moon and then Earth to change the spacecraft's speed and direction. The flyby of the Moon increased JUICE's speed by 0.9 kilometers per second relative to the Sun, guiding JUICE towards Earth. The flyby of Earth reduced the spacecraft's speed by 4.8 kilometers per second relative to the Sun, guiding JUICE onto a new trajectory towards Venus. Overall, the lunar Earth flyby deflected JUICE by an angle of 100 degrees compared to its pre-flyby path. The inherently risky flyby required ultra-precise real-time navigation, but is saving the mission around 100 to 150 kilograms of fuel. Spacecraft operators gave JUICE slight nudges to put it on exactly the right approach trajectory. Whilst the main goal was to alter JUICE's trajectory, the lunar Earth flyby also provided an opportunity to test out JUICE's scientific instruments in space, with all 10 switched on during the Moon flyby and 8 switched on during the Earth flyby. This lunar Earth flyby actually reduced JUICE's energy, redirecting it towards a meeting with Venus in August 2025. That Venus flyby will boost JUICE back out towards Earth. The spacecraft will fly by our home planet again in September 2026 and January 2029, gaining 2 more boosts before arrival at Jupiter in July 2031. This week, Blue Origin announced a target launch date for its newest rocket, New Glenn. The mission aims to send NASA's ESCAPADE spacecrafts to planet Mars no earlier than October 13th. Over the past few months, Blue Origin has performed many important tests of New Glenn hardware at Launch Complex 36. These are all important for gathering data before the rocket's first flight. In early July, retraction tests of the New Glenn transporter erector system were performed at LC-36. These tests involved the large TE pulling back from the vehicle and disconnecting umbilicals from the first and second stages. A New Glenn first stage aft module was spotted at the GS-1 test area, which sits about 150 meters east of the launch pad. Blue later confirmed that the aft module was undergoing testing, specifically showing off the deployment of the 6 landing legs that are housed within the module. The company's CEO Dave Limp confirmed the aft module is flight hardware. This test shows off the company's ambition to attempt a landing of New Glenn's first stage on its maiden flight. New Glenn forward module had completed validation tests. Dave Limp posted on X that the module had completed validation tests on the module that included firing the reaction control system, vital for controlling the booster in 0G and during descent, as well as testing the 4 large fins which help steer the booster. Both of these systems are very important in allowing New Glenn's first stage to become reusable. with Blue Origin expected to attempt a landing of New Glenn's first stage on the very first flight. There's a lot more testing to be done than just with the rocket. In early August, Blue transported the GS-1 simulator from LC-36 to Port Canaveral for the first time. Upon arriving at the port, the simulator stage parked up against the breakover fixture, BOF, which will be used to shift recovered boosters between vertical and horizontal. On August 8th, the large crane and BOF worked together to lift the 58-meter-tall simulator booster from a horizontal position on its transporter to a vertical position. Following this lift, Dave Limp posted on X and hinted that future tests will involve a full recovery rehearsal with the company's landing vessel, known as Landing Platform Vessel 1, LPV-1. This landing platform began its transatlantic voyage to Port Canaveral on August 8th. Sporting Blue's signature feather logo on the deck, LPV-1 is expected to arrive at the Space Coast in late August.